A DHCP server plays a crucial role in IT networks because it helps to provide a plug-and-play environment. But even in a small network, it pays to have your own dedicated DHCP server, because if you run this service from a firewall, then it makes it more vulnerable to exploit. Now, the original ISC DHCP server has gone end of life, so we can't expect any further updates. In its place is a more modern DHCP server called Kea. But how do you install and configure Kea on Debian distros such as Ubuntu and even Debian itself? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. And because this video is specifically about how to install and configure the Kea DHCP server, I'm going to assume that you've already got a server available which has the operating system installed. Now, Kea is supported on multiple Linux distros, but in this video we're just going to be focusing on the popular Debian ones, in which case you'll either need a server running Ubuntu or Debian. Now, because I want to cover both Ubuntu and Debian in this video, we won't be using the sudo command, and that's because it's not included by default in Debian when you install it. In which case what we need to do is to switch to the root account. So on an Ubuntu server, what you do is type in sudo, then su and a dash or hyphen, hit return, and it'll prompt you for your own account password. So I'll put that in. And now as you can see, we're logged in as root. So if I switch to this Debian server, this is slightly different because we don't have sudo installed. So we just type in su, then hyphen or dash, hit return, and now we're being prompted for the root password. Now, when you actually install Debian, it does actually ask you to create a root password. So in which case you should know what that is. So I'll put that in, hit return, and now as you can see, we're logged in as root. Now, there are different ways that you can install Kea, but what we're going to be doing is to install the official packages. But before we can do that, we do need to install some dependencies first. So I'm going to paste in the command for that, and I've got -y at the end so that we don't have to answer the prompt. So I'll just hit return, and off it goes and installs all of the actual software. Now, in order to make sure that we install the latest version and that we stay up to date, the ISC are recommending that we use their repositories to install this software. Now, you can install these manually, or they do actually provide a script that you can use. The only thing to bear in mind is that we're running this as the root account, so it is worthwhile actually checking the script before you use it. So I'm just going to paste in the actual line to install these repositories, more specifically to run this actual script file. It is quite detailed in what it does, and one thing you do need to bear in mind is it has a version number against it, so you do want to actually check the website to make sure that this is the actual latest version that you're installing. But essentially what it's going to do is to download this script file, and then it's actually going to execute it. So I'm going to hit return, and then off it goes, and it does a lot of checks, really just to install what are the repositories, but this will be able to cover against different types of actual Debian distros. Now, while you can install all of the packages, Kea is modular in design, which means that you can actually choose to install what you want. So in my case, I don't use IP version 6, so I can actually choose to only install an IPv4 DHCP server. And the good thing about that is that if there's ever a memory leak, for instance, or a security vulnerability in the IPv6 software, then it won't affect me. So in order to install the IPv4 DHCP server, I'm going to paste in a command, put the -y at the end just to save having to answer the prompt. And what this will do is just install the DHCP IPv4 server. So I'll hit return, and then off it goes and installs the actual software. Well, now that we've got our software installed, the next thing to do is to actually configure the DHCP server. So we're going to switch to /etc/Kea. If we have a look in here, there is one file which is the configuration file for that DHCP server. Now, if we actually have a look at that file though, there's just too much information in here. It's not really a file you want to be using to actually manage something like this on a day-to-day basis. It's useful as a reference file, but that's about it. So what we're going to do is to actually rename this file so that we can actually keep it for reference purposes. And then we're going to create a completely new file. And then what I'll do is I'll copy and paste in and just a really basic configuration. So go right to the top here. So what I'm doing is, for security reasons, I'm limiting the actual interfaces that the service will listen on. So in this case, I'm actually restricting it to ENS 160. Now what that is really depends on the actual computer that you're using. But in this case, that's the interface I want to be using DHCP on. Then what we've got down here is another section, which is for the actual leased database. Now these are basically the actual default settings, but when you've got a DHCP server, you actually want to keep track of the IP addresses that are being leased out. Now you can actually point this to an actual database, but in this case we're using a CSV file. And this interval here is just to do with a cleanup. It is the default setting, and the idea is that any stale entries, for example, that are in the actual DHCP database that we've got here will get cleaned out, and it runs every 1 hour. So that's at 3,600 seconds there. Below that, we've got our timers, which actually determine how long a computer will retain an actual IP address, how long the IP address is being leased for. What I've done is I've actually increased these to be just beyond 8 hours, which is your typical sort of like 8-hour working day, for example. But you can actually change these to something else. You've just got to bear in mind the actual settings. So this is the main actual lifetime. This one is 87.5%. This one's 50% of that setting. So you've got to keep that actual format there. But the idea is you can actually lower these, for instance, if you've got like a guest network, for instance, where computers are regularly going to be changing. So maybe you want to reduce it down to 1 hour for a lease. Otherwise, you run the risk of actually running out of IP addresses. On the other hand, maybe you want to increase it on a network where there's very few changes. But those settings are reasonable to go with. As I say, they're just beyond like 8 hours. The next thing that we've got is what are basically the general options. So these are the actual options that are provided to clients that are going to be common to all subnets. So up here we're defining actual DNS servers. So I've got 2 here. And then we're defining what the domain actual search is that computers use when they're doing local searches for DNS resolution. And then down here is where we actually define our pool that we're setting up for our subnet. So we define the actual subnet. So in this case, it's 172.16.21.0/24. So this is the actual local subnet for this DHCP server. And then here we're actually defining the pools for that actual subnet. So I'm setting up a range of IP addresses that can be leased out from .100 to .199, and you can actually set up multiple pools within that subnet if you want, but again, this is just a basic example. And then we've also defined the actual option data that is specific to this actual subnet, and that is typically going to be what the default gateway is. So in this case, it's 172.16.21.254. Now what you can do is you can actually set up other options within here. There's a lot of different options you can choose from, and you can even set up ones to override your global options if you want to. But aside from that, you can add in reservations if you want to reserve IP addresses for specific computers, and you can also set up multiple subnets as well. But in any case, this is just a basic example we're going to be using, so we're going to save that file. Just have a look in here, because we're actually logged in as root, and I want to make sure that the permissions for that file stay the same. So I'm going to change the actual permissions for that file just to keep it consistent. The other interesting thing I've noticed is that the actual service actually starts. The software has been installed and it's actually already running. If we have a look at system systemctl status isc dash. The actual service itself is already running. Now, we've made changes to the configuration file. I mean, granted, we've actually completely replaced the file, but if ever you're going to make any changes to this file, you do need to restart the service because it reads it when it boots up. So what we want to do is to actually restart the actual service. Then we're just going to check to make sure that it is still running and it hasn't found any faults in it. Now, one thing I will point out, though, if we go back to this configuration file, this is all stored in JSON format. So you can see you've got commas that separate out where there's continuation. You don't have a comma at the end of a line where that line is the last lines. So you've got to be very, very careful in terms of how you actually configure this file. It's probably best if you've got an actual text editor that can actually read and format JSON properly. But in this case, I'm just using Nano. But what you might find, for instance, is if there's an actual mistake in the actual way you've got that structured, then the actual service itself may not actually start. It might give you some clues within the actual lines that we're seeing here as to why it's not working. But typically, as long as the service is working, you should be fine. But what you can also do is to actually check the actual syslog file. So if I have a look at /var/log/syslog. So I'm just using tail to have a look at the end portion. You'll see it tells you some details about what's going on, and you can typically use this to find out if there's any errors popping up, for example. Well, the DHCP server should now be up and running and leasing IP addresses out to clients. And one way you can actually check what actual IP addresses are being leased out is to check the database. Now, in this case, we're using a CSV file, so that's what I'm going to check. So we'll have a look at that. And this file is actually empty, apart from just the column headers that make up the structure of the database. So what we're going to do is switch over to a Windows computer. Now, I've got all of the interfaces disabled, but I'm going to actually enable the interface that's in the same network that this DHCP server's in. And we'll see if it actually leases an IP address. So it's set itself up and it's referencing this network as network 6. If I have a look at the status and then the details, it's saying that it's got an IP address of 172.16.21.100. So that is actually the first IP address that's available in the pool. We've got a subnet mask. We've got the date and time the lease was obtained, when it expires. We've got our default gateway here. The actual IP address of the DHCP server, which leased this IP address. Then we've got our DNS servers. And then right up at the top, we've got our actual search domain. So it looks like that's worked. So if we come back to our actual DHCP server and have a look at that file again, you'll see we've now got an entry. And it's giving us the IP address that was leased out. Then what we've got here is the actual MAC address for that network card, but we've also got the client ID plus various other information, including the actual host name here. And in this case, it's called Win1. So this is actually quite useful in the sense that if you ever do want to do like reservations, for example, or you're looking for information like the MAC address or the client ID, you can actually get that from this database file that we've got here. But essentially what we've now got is a working DHCP server. Now, if you want computers to have the same IP address all of the time, rather than actually manually configuring the IP address on a computer, you can actually reserve an IP address within DHCP. So to do that within Kea, what you need to do is edit the actual config file that we've got here. And if we go further down right to the end here, what we need to do is to add in some reservation details. So I'm going to paste in some examples. Now, because we're actually doing continuation, I need to put a comma here. Otherwise, there's going to be a problem with the actual structure. But essentially what I'm doing is the actual two common ways of reserving IP addresses for computers. One is based on the MAC address. In other words, when our Windows computer here connects to the DHCP server, that's the actual MAC address for its network card. And we're telling the DHCP server here to reserve this IP address. So rather than giving it an IP address within the pool here, it's being told to give it 172.16.21.30. One thing to point out is that IP address is outside the range of that pool, and because it has to be, your reservations cannot be an IP address within the actual pool of IP addresses that are being leased out. And then what I'm also doing down here is just similar sort of thing, except using the client ID for reservation, and that's for a Pop! OS Linux computer, so that's its client ID, and I'm going to tell it to lease that IP address. So we're going to save that file. Now I do need to actually restart the service because I've actually made a configuration change. And just to make sure that there wasn't any syntax errors here or any problems with that config file, we'll check the status. So no particular problems. So what I now need to do is to go and bounce the interfaces on those two computers. And then what they should do is actually have an IP address which is actually reserved in DHCP rather than an actual dynamic IP address. So I've bounced the interface on the Pop! OS computer, and sure enough, it's now using the reserved IP address. So we'll do the same on our Windows computer. So I'm going to disable its network interface, and then I'm going to re-enable it. If you have a look at the status of this interface, go to details, you'll see it's now actually got that reserved IP address of 172.16.21.30. Now, although we made a change to the DHCP server, the actual computer here, the client computer, it'll hold on to that IP address until it either expires or every so often it does do a check. But you've actually got to essentially force the actual computer to actually go back to the DHCP server to ask for an actual new IP address or to see if it can actually keep its existing IP address. In this case, because we've reconfigured the DHCP server, our Windows computer is now being told, well, going forward, you're now going to use 172.16.21.30. But if we go back to the actual DHCP server itself and have a look at the database, what you'll find is there's actually a lot of entries in here. And this is partly why we've got this timer that runs. It's a cleanup timer, which basically every hour by default, it'll go through the actual database here and it'll remove entries that are no longer relevant. So you can see we've got multiple entries for .30 for times when I've been bouncing that interface. We've also got the old entries of 172.16.21.100 for our Windows computer, which is no longer relevant. If we don't have this cleanup, then you'll end up with a very, very big file to manage, but also a lot of it's just stale information. It's not relevant anyway. So it helps to have this cleanup running regularly. But in any case, we've now actually got two computers which are actually reserving IP addresses through this DHCP server. So those IP addresses will always stay the same. That's especially useful when you've got firewalls that restrict access based on IP address, for instance. But one other thing I do want to point out is if you come back down to where I've actually placed these reservations. Now, these reservations are specific to this subnet. That's why it's a continuation of this particular block, if you will, the subnet that we've got. If you're going to have multiple reservations, and they're going to be in different subnets, then you've got to define those reservations against that specific subnet. So it's lower down that we actually start adding more subnets, and they'll potentially have their own reservation entry. So you don't just put them all in this one area here. These ones are specific to this subnet that we've created here. Another thing to point out is that I've also put in hostname entries. Now, sometimes what you find is that computers don't actually hand over a host name, in which case this is very useful, especially if you use dynamic DNS, because the DHCP server needs to hand over the host name of the computer that leased the IP address to the DNS server. And if that hasn't been passed over by the actual computer itself, then we don't have an actual host name to give the DNS server. So that's part of the reason why I'm putting these in here. Another thing to bear in mind is these host names that we've got, they are actually unique. In other words, if you've got a computer that's got multiple network cards, for example, it can't have the same name in multiple subnets. It's got to be different. It's got to be unique for each of its network cards. That's something to bear in mind. But in any case, we're now actually reserving IP addresses for our actual computers within DHCP. Now, typically a DHCP server will actually be providing IP addresses for multiple subnets, not just its own local one. In which case, if you want to actually provide IP addressing for other subnets, you need to configure the actual DHCP server with additional subnets or pools. In which case, I need to make a configuration change to this DHCP server and tell it about this other network we want it to work in. So what I want to do is I want to paste in a configuration for another network that I've got. Just going to move that across there so it's in line. But it's essentially just the same as what we started with originally, where we're defining a subnet, a pool for it. In other words, a range of IP addresses that we're going to lease out. And in this case, just one specific option data, which is the default gateway. Again, because we're using JSON, I need to put a comma in there because this is a continuation of that other block. So we've got multiple blocks now. We've got that subnet block there, and then we've got another subnet block there. So that's why we've got to have that comma there. This is the last one, in which case we don't need a comma there. But what I'm going to do is save that configuration file. Because we've made a change, I do need to restart the actual service. And then we're going to check to make sure that it doesn't have a problem, or at least nothing particularly obvious. Okay, well that seems fine. Now, the only thing to bear in mind is that so far what we've done is to define a local subnet for the actual DHCP server. That worked fine. Now what we've got is a completely different network, in which case I need to go off and set up what's known as a DHCP relay to actually forward DHCP requests across to this DHCP server. Now, that is beyond the scope of this actual video. Really, the video is just about the actual Kea DHCP server itself. How you set up a DHCP relay agent really depends. Maybe you've got it configured on a firewall, for example, and it's different depending on the vendor. Maybe you're going to have actually have that on a layer 3 switch, and again, it's going to be different depending on the vendor. So I can't really show you any details specific to your circumstances as to how you configure that, but that is something I need to do. And then after that, what should happen is when a computer boots up in this other network that we've now defined a new pool for, the DHCP relay agent should pick that request up and forward across to this actual DHCP server, and it should then lease out an IP address to it. Well, I've configured the DHCP relay agent and I've got it pointing to our DHCP server. I've also actually configured the Windows computer that we've been using to give it a new network interface, which is in this new network. And for that reason, I've disabled the other interface. So if we go to the status for this actual network card and then select details, you'll see it's actually got an IP address of 172.16.25.100. So in other words, it is getting an IP address from our DHCP server, and it's actually picked out the actual first IP address as we'd expect from the pool. We've got our default gateway here, which is specific to that subnet, but then we've got the same DNS servers and the same domain name search because they are global options. And the IP address of the DHCP server stays the same as well. If I click on close and just close again, essentially what's going on is this computer is just sending out broadcast requests for an IP address on the local network that it's in. There isn't a DHCP server there to answer that request, and that's why we need the DHCP relay agent. It picks up those broadcast requests, forwards it across to the DHCP server we've told it about, and then the DHCP server then handles that, assuming it's been configured to deal with that specific network, which in our case it has. So if I go back to our DHCP server, and what we're going to do is have a look at our actual database file, because what we should see, I don't want to read only, is we've got an IP address here, 172.16.25.100, which has been assigned to our Windows computer. Key things to point out are that the MAC address here is different to the MAC address that this computer has in the other network. Same thing goes for the actual client ID. They are specific to the actual network card. So if you've got a computer with multiple actual network cards, for example, and you're going to have to bear that in mind if you want to give it different reserved IP addresses in each different subnet. You need to make sure that you're using the correct MAC address or the correct client ID to be able to make that reservation. But the key thing now is that we've now actually got a DHCP server, which is actually servicing multiple subnets. Now, as with any other computer, it makes a lot of sense to add in additional security in order to restrict access to the service that it's running. Now, this being a Linux computer, you could use, for example, the uncomplicated firewall to do that. But how you install and configure UFW is beyond the scope of this video, although I do cover it in another video if that's something that you're interested in finding out. Now, as far as this DHCP server is concerned, because it's just a demo that I've got here, I've got one rule to allow access to TCP port 22. In other words, this is to allow access to SSH. And I've got it restricted to one specific computer, which is the management computer. And I'm also using the limit option here in order to slow down brute force attacks, for example. The next two lines that we've got are to allow access to the DHCP service. So I'm allowing access to UDP port 67, but only from the actual subnets that we will be providing IP addressing to. Now, one thing to bear in mind is that when a computer first starts, it doesn't have an IP address. It actually sends out layer 2 broadcasts. So the firewall can't do anything about that type of traffic. But once a computer has an IP address, it will actually connect to the DHCP server going forward. So we have to have these rules in to allow that type of access. One thing to bear in mind is that when you're using a DHCP relay agent, you have to allow access from whatever IP address that's sending its traffic from. Now, in my case, I'm actually using the firewall to actually provide that DHCP relay agent, and that actually has an interface in this same subnet the DHCP server's in which case that rule is actually covering the traffic that's coming from the DHCP relay agent. Now, because the firewall can't restrict that layer 2 broadcast DHCP traffic, it is actually best to disable the DHCP server from listening to it. But that's only possible if your DHCP server isn't providing IP addressing to computers within its own local subnet. So ideally what you should have is a DHCP server in a subnet with other critical servers, and they've all got static IP addressing. So assume you can actually configure your DHCP server to ignore that broadcast traffic. To do that, what we need to do is to edit our actual configuration file, and I need to put in a new line in the interfaces block to basically tell it to stop listening to that broadcast traffic. So we'll save that file, and then what I'm going to do is to restart the service. And then just double check that it hasn't come back with any errors. Okay, so that seems fine. So if we go over to a Windows computer, this has got two network cards. This one connects it directly to the actual DHCP server, so it's in that same local network. So if I enable this interface, what should happen is eventually it'll give up trying, because it's sending out broadcast requests because it doesn't have an IP address, and it's trying to find out if there's a DHCP server on that actual network. Well, the DHCP server is not listening, so what we should find is that this just doesn't get an IP address from the DHCP server. This interface, on the other hand, is in a completely different network, and it's being serviced by an actual DHCP relay agent. Now, when we enable this one, what's going to happen is the relay agent will pick up that request and it'll send it directly to the actual DHCP server. So as you can see, that was pretty quick. Actually, it's come back and with an IP address already by the looks of it. So yeah, so it's already got an IP address, so that's working fine. And that's what we want. We want to block the broadcast traffic but allow the direct traffic. So that works perfectly fine as long as you've got that relay agent. But this interface, as you can see, it's still just basically spinning its wheels essentially. As I say, eventually it'll give up. And what you end up with is this situation here where you get what's called an auto configuration IP address. But the good thing about this is we've tightened up the security. We've got a firewall on the actual server to restrict access at layer 3 and upwards, but we've also disabled that layer 2 broadcast traffic as well. Now the final thing to consider is how to deal with computers that are being moved between networks. So for example, let's say this Windows computer, it gets plugged into somebody else's network. It obtains an IP address through DHCP. It's then disconnected from that network, brought back to our network, connected to our network, and then there's a problem because it's still holding on to an IP address from somebody else's network. Now by default, the actual DHCP server that we've got, whether it's the original ISC DHCP server or this newer Kea DHCP server, they both behave the same in that they just ignore the actual client. This computer is going to end up with an IP address that's in essentially the wrong network, and it can't connect to anything within the network. It can't reach anything beyond as a result, and it's stuck. And that is deliberate. The reason being is that you don't necessarily know if that is a wrong network, or at least the DHCP server doesn't. So that's why by default, the DHCP server just doesn't listen to these requests. It just ignores the computer. Now what you can do is actually reconfigure the DHCP server that we've got to be the authoritative DHCP server. Then what happens is when this computer talks to Kea, it basically refuses to allow it to keep that IP address, and it forces it to use one from its own pool, and that does fix the problem. So to do that, what we need to do is to go back to the DHCP server and reconfigure this. Now, how you do this depends on the situation, but what we're going to do is we're going to place a command into the global block. So this affects all subnets. You can actually do it on a per subnet basis if you like. So we're just going to paste this command here. Because I'm pasting it between the little sections here, that's why we've got the comma at the end there. By default, that is set to false, so that's why I have to introduce that as a line and set it to true. And then what we're going to do is restart the actual service. For that to take effect. And I'm just going to check to make sure it's not reporting any issues. So as I say, there's different ways you can configure that. In this particular case, it's gone into the global block, so it affects all subnets. But you could also paste it in as a line for individual subnets, if you like, so it's entirely up to you. But what it would mean then is that if this computer were to be connected to somebody else's network, come back with the wrong IP address, the DHCP server would then force it to use an IP address from our network going forward. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.